I'm Heather Poirier, Marketing Manager of Blue Marble Geographics, and I'm here with Sam Knight, the Director of Product Management.
Good afternoon, everyone.
So, Sam, we're going to talk about seismic data today, is that right?
That is correct. Today we are going to be talking about a variety of different data types, but most specifically concentrating on seismic data processing in the calculator. So we're going to be talking about really 4 or 5 main types of data. SEG P1s, there's a variety of SEG data, so we're going to be talking about SEG P190s. We're going to be talking about the new SEG data, SEG P111. We're going to talk about the binary version of SEG data, SEG-Y. And then we're going to also get off into the hydrographic stuff like UCOA, and we'll talk briefly a little bit about SPS. But mainly we're going to be talking about those different types of data in the context of 3 main interfaces in the Geographic Calculator. We're going to be talking about the point database conversions job, which is really one of the most well-known jobs in the calculator tools. We're going to be talking about the Seismic Survey Conversions job, the specialty job designed just for these formats. And we're going to be talking about the Seismic Data Import Wizard, and that's the tool that we're going to use to help actually get data into the application, even if it's not very cleanly formatted, that kind of stuff.
Okay, so if you have any questions during the presentation, you can use the questions toolbar on the GoToWebinar to the right of your screen. Our panelists will try to answer all your questions as they're submitted, and we've also set aside some time at the end.
And also, after the session, if you don't think of a question right away, have something later, you can always email us at geohelp@bluemarblegeo.com. And Heather, we've also got some upcoming conferences and that kind of thing that we want to mention as well.
Yeah, that's right. We've got a lot of conferences coming up over the next couple of months. Too many to mention them all. But if you visit our website, you can go to our events page, and they're all listed out. A special note to our upcoming Blue Marble User Conference on October 30th. It's listed in conjunction with Gita's Oil and Gas Pipeline event, and it will be in Houston, Texas.
Okay, that should be a pretty good time. We've got some interesting speakers lined up, and I think that's about it. So let's, should we actually get started here, Heather?
Sounds good, Sam.
Okay, so we're going to hop right over into the Geographic Calculator. I'm going to fire up our 64-bit version. This is the latest release of the application. There we go. We have a long list of jobs running down the left side of our screen in our project manager. All of these various jobs that we have over here relate to a number of different types of functions. Specifically, we're going to be talking today about the seismic jobs, and what I'd like to start off with here, we're going to take advantage of some of the new polling tools that we have here in our GoToWebinar panel. So I'm just going to pop up a quick poll here asking you if you could basically self-rank your level of experience. So I'm going to be launching a poll here, and if you wouldn't just mind clicking on what level of user you are, whether you're a brand new user, occasional user, maybe once every couple of weeks, every couple of months, that kind of thing. If you're a power user, you're in it all the time, or if you're somebody that's actually in charge of rolling out the software, deploying the software, that kind of stuff. I'm going to leave this open for just another few seconds here. And looks like we got a little bit of everything. And I'm going to give you maybe 2 more seconds here, and I'm going to close up the poll. Okay, so let's put that up there. Looks like we've got a very heavy majority here of brand new users. So maybe I'll take a very, very quick overview of some of the basic operation, and then we're going to jump right into the specifics of seismic data. So let's shut that poll off, and we're going to come right back to the application here. So in the Geographic Calculator, again, we're in the 64-bit version of the 2013 Service Pack 1 release. This is the release we just came out with a couple of months ago now, first major service pack for the 2013 edition. This application is essentially an all-in-one data conversion tool for geospatial data. For those of you who are brand new or just evaluating, what this is all about is geodetic conversions and some various types of calculations. Since we have a lot of brand new users here today, I'm just going to use our interactive conversions panel here as a very, very quick intro, and then we're going to jump into the deep end of the pool. So our interactive conversions here, you'll see this is the first job listed in our project manager over here on the left. The interactive conversions allow us to perform single point conversions. So here I have one single numeric coordinate. In this case, it happens to be a simple latitude and longitude position. I have some common tools that we're going to see on all of the interfaces that we're going to look at here for the actual coordinate conversion settings. Tool in the center for picking the specific datum transformation or the coordinate operation that we're going to use to get from our source coordinate data to our output coordinate data over here on the right. This interface is really about as simple as it gets. This is the job that started it all with the calculator 20 years ago when we started the company, and it's still there, hasn't only really changed in what's available under the hood. Very, very simple tool here. So in this case, if I'm going to be going from 44 degrees north and 70 degrees west longitude relative to the NAD27 coordinate system here in North America, I'm going to be transforming that out to the NAD83 system in this case. In the center, we have the coordinate transformation. So this is going to be a dynamic operation. We put in the source data that we're looking to convert. We're going to define the source and target systems. We double-click in the coordinate transformation box, and it's going to bring up an interactive dialog that helps us narrow down to pick the most accurate transformation available for our data. This is really the sort of common backbone of all of the tools that we have throughout the Geographic Calculator. Picking the most highly accurate systems and transformations available, that's really what the whole application is about. So in this case, one single coordinate, we can go ahead and fire off that calculation, get our position relative to our output system. That's really what the calculator does. It is, at its most basic level, it is a coordinate conversion tool or coordinate transformation tool. It does a number of other types of operations, calculations of distance and azimuth between points, things like forward and inverse calculations, where it's not necessarily a conversion, but really the main point of the application is for a coordinate conversion. So I mentioned these are going to be common parts of the application, the coordinate system controls down here. Just very, very quickly on these. To change the systems, we have some optional tools that allow us to either pick a system by a map. I'm going to skip this for this operation. Lets us filter the operation geographically to narrow down the coordinate systems we're looking for. But the panel that comes up, if you skip the map or if you go through the map, you still come to this panel. What this does is organizes all of the different types of coordinate systems and geodetic objects that we have available for conversion. We store all of these parameters in two main data files. There is a stock data file, that is the geodata XML you see at the top, and then there is a custom data file where all of your user stored or your corporate proprietary parameters could be shared between users. Two different archives where those are stored for different levels of access and protection through some of the administrative tools that some of our power users may be familiar with. Down the left-hand side of the dialog here, we see the categorization, how we sort out all the various systems. Systems are applied to different parts of the world, so we organize these geopolitically. First by major category, the type of coordinate system, things like geocentric, geodetic, those are all our lat-long systems, and down at the bottom are projected systems. Then by continent and smaller political or geographic regions through there. Each of the entries in the database here can be fully explored, so we can pop those open, examine all of the parameters that make that geodetic definition a thing. They make them unique to each other. They define where they're found, so the envelope gives us a geographic bounding area where those are used. Things like point styles, what type of coordinate comes out of a given system, the base datums for those things, sometimes vertical references, and then various identification information. Things like EPSG codes, software codes to find these in other libraries of coordinate systems. A number of ways to get more information about whatever that coordinate system happens to be. There's a search tool at the bottom to navigate through there. Sometimes you may not know where a particular object is, so we have a very simple search tool that helps us cut through all of the folders, find things by name, find things by parameter, and such. Once we've selected our given coordinate system, we simply come back to the main interface, and that gives us access to all of those conversion tools, things like the coordinate transformation, the output systems, things like that. So this is the interactive conversions, and I mentioned this is really our most simple form of the interface. Where this gets more complicated is when we're dealing with more complex types of data. So we're going to get into some of the other things that we're going to be taking a look at. If you are brand new to the application, you might be noticing that I have a lot more jobs down the left side of my project manager over here. I have a number of specialized jobs that we're going to be taking a look at, just a few of them. But what these all are is a workspace that I have generated for myself that I can load over and over. So when I started the application, this workspace simply loaded right up with all of my predefined settings. We're going to come back to that idea a little bit later as we start talking about things like multiple conversions, batch transformations of different types of data, and so on. Everything here from the Service Pack 1 folder down to the bottom is all stuff that I have saved in place in my own given workspace. So we're going to be stepping through some of those predefined jobs. So I mentioned a few different formats of data that we're going to be dealing with. So various forms of SEG data, whether it's ASCII or binary tables of seismic data, UCOA data, the new SEG P1 11. We're going to be talking about three main interfaces on those. We're going to be talking about the point database conversions job. This is the second job we see there, where we have some table formats that we're going to be talking about. We're also going to be working in the Seismic Survey Conversions job, and this is a purpose-built job. We're going to be mixing and matching a little bit between the two of those because they do have slightly different functionality, and there is a little bit of overlap. You can do some of the same things in both of those jobs. So we're going to be taking a look at some specific types here. It looks like we've got some questions rolling in already. Heather, should we take a pause and take a quick question?
Sure. We've got a question about which jobs to use which type of data for, and why there are two jobs up there. Can you elaborate on that?
Yes, that's actually where we're going right now. In the given types of data, so I mentioned we have the point database conversions job and the seismic survey conversions job. So the table formats of data, sort of your average spreadsheet type data. The example I have on screen right now is actually a saved Excel sheet. So it's not seismic data. We're going to be loading some seismic data into this interface. And I mentioned there is some overlap between those. So the five main formats we're going to be talking about today there are three different SEG formats. There's UCOA and there's SPS. Those are primarily what we're going to be concerning ourselves with today. Due to file structure things, and this is simply how the data is stored and visualized within a given file type, it makes a little more sense to handle some of them in the seismic survey job and some of them in the point database conversions job. The main difference with some of the file types that we're talking about here are the structure, whether or not each of the rows of data is the same column structure, so the same widths, the same number of characters on each row, and things like that. So where we're going to be focusing a little bit here is on the point database conversions job. We're going to take a look at first I'll take a look at the settings on this just basic spreadsheet. Then we're going to take a look at a version of the point database conversions job where I've got some SEG-Y data loaded in, and that is a binary type. and we're going to talk a little bit about the structure of that data. Then we're going to flip over and we're going to handle all of the other types over on the seismic survey job. And this is due to some streamlining that we've been able to add. They're sort of similar interfaces. We're probably going to clarify that a little bit more as we go. But actually, since we're starting off here talking about formats and which job to end up on, I'd like to actually take another quick poll here. We have our second poll on what type of seismic data are all of you folks working with. So I'm going to launch the poll here. You're going to see this poll hop over. This is a multiple choice. You can pick, you don't just have to pick one. But if you could let us know which specific types of seismic data you are working with, that might inform which one of these jobs I spend the most time talking about. Okay, looks like we had a strong showing for SEG P190. Some of those other formats are coming in. Oh, got some good activity here. And we have a lot of folks hitting other, which is kind of interesting. For those of you folks who are hitting others, we'd love to hear some specifics on what types of seismic data you're working with. I'm going to leave this open for just another couple of seconds. If you haven't voted yet, go ahead. Looks like we're slowing down here. All right, I'm going to close that poll, and let's take a look at what we've got here. So about half of you are working with SEG P190. I've got to say I am not shocked about that. I'm kind of surprised about the SEG P111. I have not heard of a lot of folks working with that yet, but we have a third of you working with that data, so that's pretty cool.
Sam, it looks like we've got some SEG P3 would be some other formats.
SEG P3, okay, that's another of the variations. There are a number of SEG types of data. The P1 is just one of them. There's 1, 2, 3, 4, 5, 6. Not all of those actually have coordinate data in them. And the ones we're going to be talking about today, basically those first 4 that we see up there on the list, I actually neglected to put SEG-Y on our list. I just noticed. Should have put SEG-Y on there. But looks like we have a pretty good mix. I'm not very surprised that UCOA and the SPS are putting in a kind of a weak showing. There are some very slight nuances that are different between each of the ASCII types, and so I'm gonna cluster the ASCII types in as SEG P1, the UCOA format, and the SPS format. There's a lot of similarities between those. We'll take a look at a little bit of everything here, and the good news is the tools are fairly simple depending on which ones of those you are using. The P111 is a little bit different, behaves differently in the application than some of those others, but let's actually just get to it, and we'll see how we deal with those formats. Okay, let me just close over my GoToWebinar tools for myself here so I can see my own interface. And we're going to start real quick here on the point database job. And we're going to start on here, just for simplicity's sake, we're going to start looking at a simple Excel sheet. I'm not going to stay on this very long. I just want to talk to this one a little bit for those of you who are brand new to the application. The point database conversions job here is primarily concerned with tabular data. Most folks are going to be loading in things like spreadsheet style data, database type data, that sort of stuff. Excel is a very good example of probably one of the most common formats we support in the application. Really what we're looking at here is columns of data, rows and columns of data, neatly structured, tells us what's in each column. In this case, we've got some projected coordinates on the left. We've got some placeholders here for a lat and long conversion in here, and we've got some other attributes. In this case, it's fairly text readable. You can look at it. It's got some kind of obvious stuff in there. The interface is designed for handling these coordinate data wherever they are in the table. There's no particular required structure in here. So we have a column settings interface that allows us to specify which columns have which pieces of data. And that's all pretty straightforward when you see something like an Excel sheet that has very nice, clean labels on them. And where it's been kind of trickier for folks is bringing in seismic data over the years. So we have all the same interfaces at the bottom there for working with the coordinate systems. So in this case, I have a simple coordinate conversion going from our projected columns of UTM-19 in meters on WGS-84 over to latitude and longitude. So that's a pretty simple conversion. Looks like your basic kind of table data information. Seismic data is not always quite so similar. So what I'm going to do here is hop down into a SEG version of this job. So this is, I'm just going to close my process manager at the bottom of the screen to get a little more real estate. Working on a fairly low resolution monitor here just for the sake of the webinar. So I'm just going to close off some of those other tools so we can see a little more of what we're talking about. This is an example of some SEG data. And SEG despite, I'm sure those of you who work with this on a daily basis know that some of its complications. SEG is actually fairly simple in terms of operating with the calculator, in that all of the columns are very neatly organized. So within the file itself, this is a binary format. It gives us all the information we need to know in order to properly label all of the column data across the top. So this is not data that actually, these headers don't actually come from the file like we might get them in a spreadsheet, but this gives us coded entries that we can use to display these labels across the top. SEG is really the format that I would steer folks to work with on the point database conversions job rather than on the seismic survey conversions job. And that is simply because there are many columns in here, and there are a number of different possible source columns. So we'll see in this case we have X source and Y source coordinate, then we have X receiver and Y receiver, and there's several other places in these files where you can actually have positions ready for conversion. The column settings panel for this allows us to pick those by name. So we actually put in the real description of what each of those columns are. It makes it very easy to find those. And in some cases, you might not want to convert all of these. And there's a few places where we can have coordinates. You might not want to do a particular operation on all of them. Maybe you just want to convert some of them. So in this case, it's as simple as finding those coordinate columns that you wish to change in there. Oops, looks like I grabbed an X instead of a Y, so I'll say Y source, X source, and we could either overwrite those, move them to another column if we wish, but this is going to maintain all of that structure for us. Every row in the SEG file is actually the same column structure as those that came above it. So it makes it very simple. There's not a lot of complication on the end user level to import this. So in that sense, SEG is actually one of the easier formats that we're going to take a look at here. So the process in here is very similar to that Excel sheet. We'd simply find the given columns that contain the coordinate data that we want to be converting. We would define the output columns based on those header names that are applied for us automatically, and that's it for the column settings. If we wanted to update multiple columns at once, at the top of the screen you'll see this conversion. So we have conversion 1, and it's a little drop down. Right now it only contains 1. If we wanted to do several, we could add one, and we could say conversion 2, and then use that same menu, and we could say do a conversion of our first one was based on the X and Y source coordinates. We could then also do a conversion on the X and, whoops, mouse got away from me there. We could also do a conversion on the X and Y receiver coordinates, overriding those in place. We could actually do 2 sets of conversions at once in the main interface here. And so we would simply set our inputs and our outputs to match on each of those. So over on the output side, we would just simply grab the X and Y receivers. And so that would have conversion 2, conversion 1 back on our original X and Y source coordinates. So this would actually do 2 things for us at once. And this is going to be a slightly different way of going about it, as we're going to take a look at with the ASCII formats of this data. So there's our conversion settings, our settings for coordinate systems at the bottom. We would potentially be getting into the header of the file. You'll see the header button right below the data table itself. We're typically going to be looking in the header of the information there to find things like the coordinate system specified for our data. We can update that header with any of the changes we're going to make, and that's going to go out with the output file. So that's going to be sort of starting simple here, if you will, on the point database conversions job with SEG-Y. So this is the one type that I'm going to suggest you stay with on the point database conversions job. The other types of data, I'm going to click back up to a seismic survey conversion here that I have set. Now, if you take a look at the data in here, we see our column names are a little less friendly. This is going to be true for each of the ASCII types of data. So what I have an example of here is a SEG P1 file. So it's a .seg extension, pretty common extension. You might also see this as a .SP1. Some folks will see a .seg P1, all 5 letters in the extension there. There's a few ways these can be recognized. You'll notice now that I've got this seg file loaded in here, it looks different. There's something different about the seismic survey conversion interface than the point database conversions interface. Namely, you'll notice there is no column settings button below the grid. We don't need to set the exact columns. You'll also notice there are 2 output coordinate systems rather than a single output coordinate system. That is the main structural difference between the seismic survey job and the point database conversions job. What we're going to be talking about here are the column structures of the data and a little bit of the nuance of importing this data. Before we do that, I'm actually going to pop this file open in a text file editor. So I'm just going to get right into my storage folder here where I have the data we're looking at. I have a little demo folder here. I'm going to take a look in my seismic file, if I can remember which one of these I put it in. Point database, there we go. I'm going to pop this open in a simple text editor. This is just a freeware text editor called Notepad++. And we're going to take a look at the raw data. So obviously we've got some fake data in here. This isn't real stuff. But it's basically got all of the same placeholders that you'll see in real SEG data. So you'll notice there's a lot of just sort of natural text at the top. Everything from the type of equipment, who did the work, various dates, signatures, that types of thing, coordinate system information, some indicators on every row of the header of this particular data file, and then it gets down into the actual data columns itself. And you'll notice this stuff is really difficult to read. It's very difficult to determine exactly which characters go in what columns, where the lats and longs are, all the various readings and line names and things like that. Nothing is labeled for us in any particular meaningful way. This is one of the tricks of this type of data, is that just by looking at it, it's rather tricky to read. But because of that, there's a lot of room in here for error. Columns can be misaligned. Somebody can manipulate the data in something as simple as a text editor like we're looking at here, and the data can get screwed up. And so that's what we're going to be taking a look at first here, is the data import wizard to actually get this data into the calculator interface itself. So back over into the calculator, I've already loaded the file that we were just looking at. This is the same exact file, that SEG P1 file. And you'll notice that we actually have broken this out into the real columns. So we can, without a whole lot of imagination, see that we have latitudes and longitudes and northings and eastings, and then all the various other readings that go along with this data file, things like the line name and the shot number and such. Now, this data as well, similar to that SEG-Y, it also has that header, and we can recognize that same header in the header editor. So we can come in here, make any of the updates that we need to make. We can take a look at the coordinate system information that we see in the header of that. We could use that to control the output of our conversion, verify that all the parameters match, that kind of stuff. If you notice at the bottom of the header editor, we've actually got some rows of data in here, and these are actual shot point rows. These are not parts of the header, but they are being misidentified as the header. And so what we're going to need to do is go through the data import tool to figure out what's going wrong with this and how to clean up this data. So one of the things we're going to look at is defining variations of these schemes to help correct data that has either been corrupted or maybe just mishandled, misformatted, and things like that. So we've got these rows that are being falsely identified as header information. When they're pulled off into the header, you'll notice they don't actually show up in the table. So my first coordinate up here is shot 110, and the first row of the file is actually shot 101. So we need to figure out how to get that stuff out of the header and treat it actually as real data. So I'm just going to close out of the header there. Now to load this data in, we're going to if we had nothing in here, we're starting from scratch, we would click this little ellipsis next to the data field, and that's going to simply open up a Windows data browser. I'm going to point it back to that same file. This is the file we're looking at already in the interface and that we just looked at in Notepad, and I'm going to open that up. And this prompt, I actually answered this prompt the very first time I loaded this data in, and it asks me if I want to use the default scheme to load this data. And that's actually what I did the first time. So when I originally loaded this data, I said, sure, let's go ahead and just treat this as if it is a perfectly formatted, normal SEG file, and loaded it up, and that's when it went wrong with the header information. So this time, I'm going to load this in, and I'm going to say, no, let's not use that default scheme. Let's actually get into the wizard and see if we can bring this in and fix up what the problem is with the header. So it's going to load our text file scheme wizard. And this is a tool you can also get to under the options menu. Over on the top left menus there, you'll see an option for seismic survey formats and just regular text file formats. It's a slightly different version for each of those types of data. It's going to launch this wizard, and it's going to identify the type of data that it is recognizing. So in this case, it's recognizing this as a SEG P1 because I have loaded in a .SEG file. And we're going to take a look at how it recognizes those in just a minute after we go through the wizard here. If I want to make a permanent copy of this variation, I could use this copy button, define the new name. I could say like SEG P1, variant for a particular vendor that puts these out, if we wanted to make that permanent. In this case, I've just got one of these files, and so I'm not going to bother making a permanent variation for this yet. We'll take a look at how we can actually do that in just a bit after the wizard here. Shows you a preview of that file that you've loaded. Shows you a chunk of the data in the preview panel, and we can actually scroll up and down through here to see the various bits of the header and the data records that we're going to take a look at. So that's just showing us the very tip top of the file. I'm going to click onto the next screen there, and we're going to see options around defining the header records. And in this case, this is actually where we're seeing the problem. So we're falsely identifying some rows as header records. And so there are a few ways to do this. Seismic data in particular has what's called a variable length header, meaning the header is not always the same length from file to file. So in one file, the header could be stripped. You might have nothing. That's a fairly common thing to see in the data. And in another file, you might have 60, 100 different rows of data in the header. And so there are a few ways to go about recognizing multiple length headers. One is that you can simply hard set the number of rows in here. So in this case, we could scroll down through our header data. I could scroll down to the bottom of that information, and I could take a look at line number 67 there. I see line 67 is clearly the end of my header information. And I could say this file has 67 rows. I could say records above the first blank line are a header. And if you've got a blank line, that's great. I could also use that setting. In this case, the default scheme, what it's going to walk you through in the wizard is it will have the default scheme setting in place for you until you change it. So what we're going to see here is that header records are identified with an H in the default SEG file scheme. So that comes from the official specification for the file. And there's this modifier down here called block length. So a block length is basically a computing term for how many rows follow the header identifier. In the case of SEG that we're looking at here, what it means is on a row that has an H, 20 rows following that are also what's called a logical block that stores that hunk of header data. So where we have an H on every single line out here, it's going to go to that last H, and then it's going to count down another 20 rows and take that all as header. But that's, not valid. In this case, our header is misdefined. Our header has an H on every single row, and the real specification for SEG data only has an H on every 20th row. So it's going to falsely identify some of that data. So in this case, what I can do for my import variation is I could actually do this a few different ways. I could say the total number is going to be 67. That would just simply pull them all in. I could say the first blank line is going to be a header row. That might cause some trouble right there with our H. That wouldn't actually work since there is an H on that row. It would need to be totally blank, so that wouldn't work so well. Or I could still recognize it with an H on every row. And in this case, what I'm going to do is I'm going to change my block length from 20 down to 1. And when I do that, that basically says every row that has an H on it, just get that row only and treat that as my header. So you'll see the highlighting indicating where the header is being recognized now stops at the very end of the header. And in that case, this is going to clean up my data fairly nicely. It will recognize all those H's and actually peel them off as a coded entry. And we'll see that in just a second here. So my header is looking pretty good now, so I'm going to click Next and get into the data rows. Now the data records, in this case in SEG data, the data records are all the same from row to row. The structure of where those column breaks is all the same. There's one little nuance here for UCOA data, and UCOA data doesn't actually have that same standard. So if you're bringing UCOA files in through this process, you're going to see this drop-down light up that has differences in column definitions between the shot point rows and the receiver records. That just gets a little extra complication, but the process here is actually exactly the same between those. So for my SEG file, what it's showing us here are the red lines, the vertical red lines that you see superimposed on the data are where the column breaks are going to be made. So it's recognizing everything up to our first column here is 1 character wide, then this chunk is our second column, this chunk is our third column, and so on across the data. This is what we call fixed width data, where we count the number of characters on a given row rather than having an explicit cell definition like we have in something convenient like Excel data. In this case, my data records are nice and clean. If they were not, if they were misaligned, and we needed to correct that, you can actually just simply click and drag on any of those red lines and place them where the actual data does change between columns. Very common variations in here are that there might be an extra character inserted uniformly from row to row, and we can correct for things like that by simply dragging and dropping those lines around where they need to be. Now the last little piece of this is there's a little difference here between some of you folks may be used to the regular text scheme wizard for non-seismic data, where there's just one little difference here for the seismic data version of this editor that we're looking at here. The number of columns is actually fixed. So in regular ASCII data import that's non-seismic data, you can have any number of columns in there. In the seismic formats, you'll notice the number of fields column setting is actually grayed out, text box. I meant to say the number of fields text box is actually grayed out. In the case of SEG data, it's going to be 15 columns. It always must have 15 columns, and they need to simply be set at the appropriate width for the data that you are bringing in. You can adjust the width of them, but you do have to have all 15 of them for it to be considered valid data. Once we've got those lined up where we need them to be, I'm going to click Finish, And this is going to then load that data according to the spec that we have just defined using that wizard. And what you'll notice is I'm now seeing shot 101 as the first row loaded in as data. If I click into the header part of that job and scroll to the bottom where we previously had those rows of data, you'll notice they're not in there. And it's also peeled off all of the H's that we see at the front. It recognizes that H as a coded entry. It will pull that off as we look at it in the header editor, and then simply put that back on output with the appropriate H on every 20 rows. We'll get to that in just a second. So again, we can make whatever updates we want to see in our header box in there and get on with the conversion. Loading the data. I'm sorry, go ahead, Heather.
Did you want to answer another question?
Sure, yeah, what have we got?
We've got a question about size limitation of data. Are there any limitations?
Okay, that's a great question. Now, as we've loaded the data in, you'll notice if I scroll down to the very bottom of this file, you'll see I've only got 50 records loaded in here, so it doesn't look like a very big file. Now, if we go back to the data file itself, and again, I'm just going to open this up in Notepad++. If I scroll to the bottom of that data file, you'll see there's actually over 1,500 records in this file. So we're handling this data in a kind of a special way. And what we do in here is we actually partially load that data. When we load the files in, it just simply loads in the very top chunk of the data records, enough to take a preview of what we have. So in this case, 50 records, and that 50 records is actually configurable. There's a preference option. You can have it load in thousands if you prefer. The reason for only loading in a few records is that typically these files get very, very long. It's not uncommon for seismic data to get into the millions of records, and that's pretty big in terms of a spreadsheet. You couldn't possibly hope to actually look at every row of a file more than a million records long. So we don't bother with that. These are theoretically uniformly formatted throughout. If they're not, that will bring up some other errors, but we'll be steered to those as we go. The short answer, I probably sound like I'm dancing around this question, but the short answer to the question is there is no limitation on the number of points that can be converted in here. What we do when we partially load that file is we're just simply going to visualize a preview of it in our table on screen. When we actually go to write that file out at the end, we're going to specify a new file location for that to go from the output data type. And the actual processing that we do in the calculator is actually row by row. So it takes one coordinate, does that conversion, writes it out to the output file, goes down, gets the next coordinate, converts it, writes it out to the output file. And in that sense, it's actually an extremely lightweight process, and it doesn't require much in terms of CPU to do the processing. It doesn't require a whole lot of RAM to do that, since we're only thinking about one point at a time. It's a very efficient in and out process. The major limitation for the size of data you can process is actually storage. It's how big the data is that you're going to be processing. So if you are, if your hard drive's getting kind of full and you've only got maybe a few gigabytes left and you're trying to process several gigabytes worth of data, you're going to run into a problem there. But typically these ASCII types are, maybe a few hundred megabytes, maybe getting up into the gigabyte range occasionally. Typically the file sizes are not that gargantuan. There are many other types of data that are far larger than these seismic types. Where the problem comes in for most folks is when you're trying to fully load every single coordinate into a given application, trying to actually load it all into memory. Because of the way we operate in here, we don't have to do that. And so there is no upper limitation other than total file size for storage on your machines. We've had common reports of folks dealing with certain types of seismic data that gets up into the hundreds of millions of records without any trouble. We get into gigabytes of data some of the larger stuff we've heard of folks running are point database jobs of seismic ASCII stored data that gets up to around the 30 gigabyte size. That's really sort of getting up to some of the ceilings of just simply what people are creating in these types of data. Much more commonly, folks are dealing with, maybe a couple hundred megabytes at a time, but again, there is no upper limit to the size of data that you can pass through here. It's only limited by your hard disk available space. So in actually doing the work to create these for output, we have the coordinate system settings down at the bottom here. Remember, we have no column settings on this. We don't ask you where the columns actually live. As a part of loading the data in, we already know. So if you step through the wizard and you realign where those latitude longitude columns are, where the northing and easting columns fall, or excuse me, actually easting and northing, I should have said there, where those actually fall in the seismic type that you're loading in our case it's a nice simple SEG file here. When we load that in, that's a part of the process, so we already know where it is. In the case of a common SEG file as I have here, C5, column number 5 is my latitude column, C6 is my longitude column, C7 is my easting column, and C8 is my northing column. And that simply is fixed from file to file that I'm going to bring in. They're always in the same place. They must be in that location. It is not valid for them to be in another location. So we actually know, based on the type of coordinate system you have in your settings, which columns to use for the conversion. So in this case, my predefined settings that I've already got here are, I have an input coordinate system of WGS84. I have an output coordinate system of WGS84 based UTM zone 38 north. So where did I get that information? We're going to take a look in the header. And down towards the bottom of this header, and it's not always going to be in the bottom, sometimes it might be farther up, sometimes unfortunately it might be completely missing. In this case, my header does actually cleanly indicate for me what coordinate systems we're dealing with. We're dealing with a datum of WGS84, datum and ellipsoid of WGS84, and in this case my file is not entirely clean. It says the datum name is UTM zone 38, WGS84. What we really know is that WGS84 is the datum, UTM zone 38 is actually the projected coordinate system, and it also tells us that in another location up at the top. So it's not the best coordinate system information coming in from this particular project. This is data that actually did come out of the field. These, the coordinate system sections, are the only section we did not mess with in creating this demo data. So this is a sample of some real stuff here. Not always super clean to read, but all the information is actually there. It does give us all of the parameters to define that system, so we can be pretty confident that the projected portion of that is UTM zone 38 on WGS84, that the lat long portions are WGS84 themselves, and that's pretty much what we need in there. So we can take that out to the main part of the interface, and we can plug those into the various locations. So in this particular file, we actually have northings and eastings and latitudes and longitudes already done for us. Now, say for example we wanted to validate the coordinates that we have coming out of this. So let's say we wanted to take our geodetic coordinates and validate the projected locations of those. I would be starting off with a geodetic coordinate system. So I would double-click in my system box over there. Again, I'm going to skip the map interface here for now, and I would browse down under geodetic, under the world category, and find WGS84. I could also do a text search for it if I didn't know where that was. We'll say OK to that. And because I've set that as a geodetic system, a latitude-longitude system, we know that you're talking about columns C5 and C6. The only thing we need to clarify there is the specific format that those are displayed in. So in this case, you'll see these latitudes and longitudes are a little bit scary to look at, but those are actually in a standard format called packed DMS. Of the many different ways you can write down latitude and longitude coordinates. Those are in a standard format called PAC-DMS, which is the standard for seismic data. At the bottom, we can see an interactive example lining up of what all of those settings total up to be. So we can set the example to match the general formatting of our input coordinates, and that's going to properly parse those out for us. The northings and eastings that we have in our projected zone, we know that our projected system is going to be covering C7 and C8. So when we toggle on this checkbox right here to turn on the projected output system, we know that that output is going to go into C7 and C8, and we don't need to be told through the column settings button as we have over on the point database conversions job. Optionally, we could also toggle on to update the geodetic output system, and what that would do for us is overwrite the contents of C5 and C6. Through turning on both of those, we have the ability to perform something like a datum transformation. So if you actually want to update the locations of an entire seismic file into a different datum, we could perform a transformation on that and put both the lat longs and the projected coordinates within that file on an alternate system. In this case, if I were just simply writing out to a projected system and I only wanted C7 and C8 to update, I would toggle on only my output projected system right there. If I needed one, I could activate the datum transformation control. In this case, I don't need one, so if I try and activate that, it's just simply going to say no transformation will be applied. It doesn't need to pick one for this operation. For actual output, down at the bottom, you'll see there are a few different types that we can possibly grab onto. There's a little drop down there, and in this case, it's only got one type. We're going to come back to that in just a second. I've loaded in SEG P1 data. It's going to let me write that out as SEG P1 data. The only other thing to run then would be to actually save that file out as a new output piece of data. So we'll call that our new file. I'm going to save that, and then we can actually go ahead and process that data out into the new file. And once that's finished, it's going to show up in our output folder. There's my new file.seg. We can take a look at that in the ASCII data viewers, and you'll see it's actually fixed up the header for us. It's added the placeholders it needs for the header to be properly recognized. You'll see the H on every 20th row as we expect to see those. And then as it gets down into the data, it's actually going to show us the updated data down in here if we had updated one or more sets of those coordinate system data. Now, I mentioned just very briefly the different variants of the data that we have. So in that output type, we'll see that we have just that SEG P1 type available for here, and that's specifically because I loaded SEG P1 data into the interface. I'm going to take a quick look here under the options menu. And I mentioned before, this is where we can get into that import wizard directly. We can define some variations in here. And this is also where we can define those on the permanent level. So I'm going to go into our seismic survey formats. And this allows us to step through that and predefine some of those variations. So that's there. I'm going to back out of this for a second, and I'm going to go into the Preferences menu. Now, in the Preferences, you'll notice there is a Seismic Survey section, and this actually lets us get access to that same thing. We can administer some of those settings around the Seismic Survey import wizard. At the very top of that, you'll notice the setting. This is where we control how many of each record we load into the data grid. In this case, it's got our 50 records up there. We can increase that if we want. We have some options about whether or not you are always prompted on load of seismic data to use the default scheme or to use the wizard. And then we get into the different types of data that we can talk about here. So all of the different variations, they have their own schemes in there, and they each have their own nuances. On the right-hand side there, for each of these schemes, you'll notice there are certain extensions associated with those. We can add new formats to add the variations of those, and then with each of those extensions, we can add the various supported extensions so that those can be automatically recognized. So that's all going to be done right here under the Preferences menu, and that's the simple difference between loading these as a one-off and actually creating these as a permanent variation. So once we've got a completed conversion, that's simply one type. I'm going to shift over and talk about a new type of data here, since some of you said you're working with the SEG P1 11. We'll talk about this one, and then we'll wrap it up with some questions in just a minute. Now, this version of the interface is a little different than the regular seismic survey conversions job. There's a couple things that are different here as well. You'll notice when you load in SEG P1 11 data, the header area actually disappears. There's no header button anymore even. There's also no output settings on whether or not to update your output projected systems and your output geodetic systems. That goes back to the requirements of the new specification. The new SEG P1 11 is very different from any of the old formats. And I'm just going to close off my process manager. That's my progress bar down at the bottom, just so we can see a little more on screen here. So this file that we have here is simply a sample file. There are coded entries on each of the given rows in one of these files. So you'll see the very first column there, HC header at the top, OGP tags as we go through some of these various pieces. This is essentially a sample file that comes along with the SEG specification. As we get down through there, you'll notice there's some color coding on there. So HC is a regular header row. There's the CC row. That's actually a comment row. And in this case, our 50 rows of data only gets us down partially through the header. In this case, we're actually going to be displaying the header right in line with the rest of the data, because the way the new specification works is you can have header rows and you can have comment rows theoretically spaced all throughout that data. It's not always just at the top anymore. As well, these files also contain, all of their coded entries, things like EPSG codes, defining what coordinate systems they're in. They can also have any number of coordinate columns. They don't have to be in a fixed order. But the way this works is the input system, whatever that's defined as, is going to be the base coordinate system. There is a set of protected columns in these files. That is what it was actually surveyed in. That is going to be what our base system is for these. And then we can update the output systems, whichever we like. If you don't want to put it into a projected system, you just pick none. If you want to put it into a geodetic system, you specify that system. If you want to put it into a projected system, you specify that system. And it's going to do basically whatever you have set for the outputs. We'll simply add those new columns if it wants them there. And it will never update the original source columns. And the reason for that is that is set by the specification itself for this data. This can be handled just in the same way for variations of this type of data. We can add additional extensions that you'll see that will be recognized with this new format. But it is a little bit different. Basically, the nuances of this is we can have those the comments records spaced all throughout. And other than that, it is fairly similar. It's the same type of data. It simply has more optional coordinate systems, things like geocentric coordinates that we don't normally have in the regular types of seismic data, where it's typically going to be geodetic or projected. There's a few more options. So the headers are a little more flexible. They don't cleanly fall through our wizard. It's a much more sort of open and flexible format. We haven't had a lot of feedback from folks that are actually working with this yet. I'm really glad to see that a third of you that are watching today are using the SEG P1 11 format. We would really love to hear from you folks, how the new interface works for you. If you've got any suggestions for you, this is a brand new interface that we added in the Service Pack 1 that we just recently released. Excuse me. Anybody that is working with this, please let us know about it. If you have any questions about any things you've run into, now is a great time to post them up in our questions panel. And I think we are running out of time. I went a little long there, so we are still going to do some questions. So let's get right into those questions there. Let's see. Yep, I see a few of you folks have indicated that you were using SEG-Y towards the beginning when I was talking about what are those other formats. Yeah, I should have added that on the poll there. Question about having multiple headers in a single file. That's a good question. There are only so many things we can do. There are certain variations of some of these files that are a little too extreme for us to handle, and it depends a little bit on the data. So I'm going to assume you're talking about first one of the basic ASCII types of data, so such as a SEG P1, UCOA P190 file, SPS, those types of things. We have the ability to pull out headers that are spaced within the data records. So if you've got some header, you've got some actual data, and then you've got some header records plopped a little bit farther down, those will all be peeled off. And so we can get those out of the data records. But the trouble we have with that is we don't have quite enough interface to put them back in. Where this typically comes in is if you've got multiple seismic lines within a single file. So if you've got, say 3 different sets of lines within a single seismic file, and they each have, they were collected separately, they each have their own header with all the same information. If it's all the same coordinate system, that's all kind of okay, and it's cool. You can pass right through, peel out those different headers while loading them into the interface. Where it gets tricky is if you have different stuff and you actually want to update those multiple headers and put them back in line. On the outputs of the SEG P1, what we want to do is put the headers at the top and then put the data beneath the headers. So if you're working with data that actually has different chunks of header throughout the file and you're in some of those ASCII formats, the cleanest way to handle that would actually be to pre-process it a little bit before you bring it into the calculator, would be to actually split those out into multiple files. It'll come through just a little bit more clear than that. In the batch processing, and each of the headers will be back at the top of each given information. Follow-up question from the same gentleman: if you reproject, does the new datum get placed in the header? And if it does, where? And this is a little bit different depending on the type of data we're talking about. In the case of the SEG P111 format that we're looking at right here, that information is added as header records. So it identifies what columns they go in. They're all the new format is designed. It's designed to be coded. So it tells you what columns, what specific geodetic definitions. That goes all along with very clearly. It is a lot of coded entries, but they all are very clearly entered in there. If you're talking about the older formats, things like SEG P1, UCOA P190, SPS, those sorts of things, that information, unfortunately, cannot be automatically updated in the header. And the reason for that, let me click back over to a regular SEG file here. In the header of those jobs, let's get this a little bigger so we can see what we're looking at. In the header of those jobs, in this case, down towards the bottom, there is some information on the coordinate system that we have. Unfortunately, that is all what's simply called natural language. It's just text. There's nothing that's actually coded in there. There's nothing in there that is standardized in terms of things that can be automatically read and updated in each file. Simple things like the ellipsoid name in here being WGS84 parentheses 1984 with a hyphen in the middle of it. There is absolutely no formatting automatically applied to that on the input data. So the possibilities of what are in there are too many to automatically support. They're not coded entries that can be recognized easily by any software package. So what the process there is, if you're going to be updating the datum, transforming to a new horizontal position on a different datum, what you need to do is use that header to update those lines that you can actually recognize yourself. If you do not have any chunks of coordinate system information in the header, you can add it right in there. You can type right in this field. Say, for example, I was going to be changing this from WGS84 to a different datum. This is actually a text editor. I could update this to say whatever I want it to say. So you actually need to get in there and make your edits by hand in there, because they are simply raw text that cannot be automatically updated with any sort of accuracy. So that's going to be true of SEG P1, UCOA P190, SPS, any of those older types of headers. And again, back over in the new format, those are all coded entries. They use EPSG codes, very explicit definitions. You'll actually see some of them in this particular file up here. Where those go is they are simply added as header records. We're going to add those in at the top of the file. We're going to add those in at the bottom of the chunks of headers that define all of the coordinate systems in there. So they'll be added right in line with new columns containing that position information. So it's a little bit different depending on which type of data you're going to be talking about there. Question on SEG P3 as a predefined option. We do not have that predefined out of the box. We do have some open enhancement requests from various users to have some of the additional SEG files predefined. We are going to be working on those, and we do hope to get some of the additional ones. I don't know if P3 has been requested. I know some folks have been asking us about P2 and P6. We are looking at those, but we'll definitely make sure we add P3 to the list and see if there's a good way for us to splice that one in there as well. Let's see here. We have questions about validation. So when SEG P1 headers are missing coordinate system information, can you perform validation by comparing the lat-long converted against the XY coordinates? That is actually a pretty good way of sort of back tracing where this stuff has come from. Anytime you are missing appropriate coordinate transformation data, coordinate system information data, it is risky. Your data is not reliable after that point. There are many combinations of coordinate systems where you might have multiple datums involved in the area. If you have projected coordinates for the latitude-longitude coordinates, it is possible for some of those to be very, very close in terms of the latitude-longitude to the projected coordinate relationship on multiple datums. And maybe a clearer way of saying that is, say, for example, you have lat-longs on WGS84, and you have projected coordinates on WGS84 in, maybe say UTM or something like that. It is possible to have latitude-longitude positions on a different local datum. So something for North America here, maybe NAD27. NAD27 is probably a little bit of an extreme example because the size difference between that and WGS84 and NAD83. In many parts of the world, there are similar horizontal datums where they're not quite so extreme in their differences. And the projected values for a given lat-long point can be relatively the same. So even though you have the base datum wrong, you might have the similar conversion of the latitude-longitude to the projected element if they're both on the same system. It is not always 100% reliable, but sometimes your best guess is all you can really get out of that. Doing that, validating the conversions, as we took a quick look at on the seismic survey job. If we were uncertain of the horizontal data modes, just say our projected system, say we were reasonably confident that our lat-longs were on WGS84, we could convert out to the suspected system and take a look. If you're getting dead-on values and you're able to reproduce those right out based on a known system, if you're reasonably sure of the datum, sometimes doing those test conversions can help you sort of get your data back a little bit. It's always a very, very good idea to make sure everybody that receives your data from after that point understands that there were guesswork involved in the data, and so there is possible positional errors in some of those. But that's a really good question with a long and tricky answer, and the real answer is you just got to really be careful when you're trying to do that. I've got a couple questions here that I'm going to have to be honest and say I don't exactly understand what the questions are. Some questions about trace math, computing horizontal trace offset from nav data. I'm going to have to follow up with you after the fact, after the session on those to get some clarification. Same attendee is asking about layback computation. Those are, I'm afraid, those are terms I'm not familiar with. So we're going to have to follow up with you offline after the session here. Let's see here. I think we've got through most of them. We have a couple of folks have asked about crossing up the various formats, such as going from ASCII-based SEG data into SEG-Y format. Unfortunately, that is not something we presently have a simple way to do. It is theoretically possible to take this would be something you'd probably have more flexible luck doing in the point database conversions interface, because it does allow you more control over the column structure. What you would need to do to change between any of these formats would be to, in the point database conversions job, you would need to be able to fully load the points. So that is not a partial load of the points. That's going to cause you a little bit of headache to do that, to fully load the data if it's very big. But you can fully load that data, and if you are able to fully load the data, you can restructure the output columns. So you can move them around, change their widths and such. And that will get you as far as being able to mix between the different ASCII-based types of data. In terms of getting over to SEG-Y from one of the ASCII-based types of data, it's not something we're going to be able to do right now. If that is something that you have a strong interest in, definitely follow up with us at our tech support email address, geohelp@bluemarblegeo.com, and we can talk about that further and see if it makes sense to look at a tool to do that a little bit more easily. Let's see here. Some questions about double data. So if you've got basically repeated points in there, if that can be automatically identified. We don't have, there isn't really an interface to check what multiple things are in there. Really what this is all about is just simple conversion, handling the coordinate data from row to row. So if you do have two, say, duplicate rows, same data duplicated on rows, it's simply going to convert it twice, and you would get that back out. So there's not really a cleanup for duplicate data in there at this point. If that's something you deal with a lot, I'd be interested in seeing some data. If you could maybe send us some samples, what kind of double data that you're getting in there, and we could maybe open up a conversation about some more data cleanup kind of issues. I think let's see here. Looks like we maybe have. Oh no, that's not a question. I think we have reached the end of our questions, with the exception of one more question. Okay, the last question we're going to take here for today is on batching data. Batching seismic conversions is something that's very common. In the case of the job I've got set up here, the single SEG file that we took a look at, the seismic survey conversion, I've already got all the settings predefined. So the first part of setting up a batch of these is in setting up one job, as we did. To actually batch these, then in the project manager over on the left-hand side of the screen, you're just simply going to right-click on the seismic survey conversion that you want to batch and use as a template. And when you right-click on that job, you're going to see an option to batch add. And in the batch add dialog, basically, I don't actually have a batch of files to run right now, but the process here is rather simple. You load in the multiple files that you want to include in the batch, similar to the one that you used as your template. We have all of the input and output settings are going to be brought in from the template, so there's not actually anything to set there for the coordinate system. It's just going to show you what you've got. And then all you need to do is set the output modifiers on the file names. So this is going to add a prefix or a suffix or both to your output files. And what I'll do here is I'm just going to grab onto that same file. I'll pretend I have a batch here. So I'm going to create a new batch of just one file. I'm going to add an output prefix of output ahead of the original file names, and I will pick an output location. I'll just write that off to my desktop for simplicity here. When we click Generate, what that actually does is it generates a new batch job in whichever project you're working in, and it's going to create a single sub-batch job for any of the files that you've loaded in. So I only loaded in one, and it's going to create that one for me. If I'd loaded in 5, I would see 5 jobs listed underneath there. All I need to do to run all of those as a batch is just simply right-click on the batch itself and say Process. And that's going to go through file by file as if you were loading these in one by yourself. It's going to run them consecutively until it reaches the end of all of those batches. So through that process, again, the only limitations on the size of the data that you can pass through there is going to be the size of your hard disk to actually write out the output data. And through that process, a lot of folks will do stuff like take large collections of seismic data and set them up to run overnight or over the weekend on a computer that's just going to crunch those jobs out for them. So batching is very simple. It's actually much simpler than just setting up the individual job itself. You start off with a template and then simply spawn that template off into a batch for all of the other jobs you want to run. So that's going to do it for what we have time for questions. Thanks to anybody who's been sticking around. Heather, did you want to mention the Blue Marble conference information again?
Yeah, I just want to invite people to come out. It's a free event, Houston, Texas. If you want more information, you can visit our website and go to our VMUC page. There's agenda and speaker information, and we'd love to see you.
Okay, great. It's going to be a good time. Heather and I will both actually be there ourselves, along with a bunch more of the Blue Marble staff. So I'd just like to thank everyone for attending today, and we will see you next month.